We're going to talk about pi and another method on how to calculate its value. So remember, uh, when we first started the series of sessions, the pi is really how many times the diameter goes through the perimeter of the circle, which is the circumference. That's how we did it. And what was the practical advice? What was the practical activity that we did? Well, I asked you to take an object, and out of that object, I asked you to draw on it. Well, this is an example of a funnel. So let's just make this a little bit darker so you can see. So that's a funnel. And then we're just going to make a circle around it. So there you go. So this way of doing things, that means that you have an idea of what it is rather than just being told. And what we did was that you locate the circle there. You recall the middle of the circle and draw the diameter. And so what we did was we measured the diameter and we measure the perimeter of the circle and we put the values in. So that's how we did it. And you came up with different values. Some of you came up with a value of around 3, some of them with a value of 3.11. Now, that is one method. Now, I reckon that throughout the history, the Babylonians and the Egyptians and the Chinese have their ways of getting or arriving at the value of pi. So in history, the Babylonians came up with a value of 3. Yes, and later on, when more tablets were discovered, because they keep discovering new tablets, and I mentioned this in some of my lectures in Babylonian mathematics. So here, later on, they found that it's a little bit closer to what we have today. It's 3.125. The Egyptians have a value that is a little bit more real. So it's 3.1605. But I reckon that all these values they got using this methodology, right? You measure the perimeter of the circle and the diameter. And then came the Greeks. And the Greeks has the most modern style or modern or theoretical method of getting the value of pi. Now, I'm going to talk about it today because the man responsible for this was Archimedes. So, Archimedes was really the first personality to come up with a theoretical method. See? And whereas before, they always measure, there's always measurement involved. But Archimedes came up with a theoretical approach. That means there's not really any measurement, but just thinking. And that's what we're going to do today, is thinking through. Now, Archimedes' method is simply the idea of inscribing a inscribing a square inside the, you see, circle. You see? So in your elementary geometry, you did speak about inscribing an object. So here when we inscribe, we're putting it inside the circle. But he also said something about circumscribing it with the same object. So basically, when we circumscribe an object, we are surrounding it with, we're enclosing it. So it's not very accurate, but there you go. So he did it by inscribing and circumscribing the circle. Now, here we think about it. Let's say that this length of the side of a square is 1. It could be 1 centimeter, it could be 1 meter, it could be 1 foot, doesn't really matter as long as it's 1. And so, then what Archimedes did is calculate what is the perimeter of the bigger square. So how do we get the perimeter? We just add all the sides. So basically, if this is 1, that's another 1, there's another 1, and there's another 1. We add them together, so we have a perimeter of 4. So perimeter of bigger square is essentially 1 plus 1 plus 1 plus 1. See? 1, 2, 3, 4. And then what Archimedes did is also work out the perimeter of the smaller square. And so, how do we do that? Well, we know that this one is 1, so the side of the square is 1, but that's also kind of the length of the diameter. So in this case, diameter is really 1, and the radius would be half of the diameter, which is really one half, or 0.5. Yes. So basically from here to here, that's the radius, which is 0.5. But we can also say that from here to here, that's also the radius, and that's also 0.5. Yeah, so from here to here. Now let's name these lines. Let's name this radius here as A. And let's name this radius here as B. And let's name the long line here as C. So we know what A is, it's 0.5. We know what B is, it's 0.5. But C, we don't know. Now, how do we calculate the value of C? Well, guess what? Any guesses? We've done this before last school year. Yes? And this is a right triangle. Anybody can remember? We calculate the value through what? Through the Pythagorean Theorem or Pythagorean Theorem. Now, what is the Pythagorean Theorem? I'm not going to really talk to it again, but maybe some of you can remember. Yes, it's basically the square of one side plus the square of the other side is equal to the square of the longest side, which is this side here. Now, let me just color this the same here. Let's just interchange this. Yeah, we'll have the same values. Is c squared equals, then we copy this one here, a squared plus b squared. And so we know what the value of a is 0.5. And also we know the value of b, which is also 0.5. Of course, 0.5 times 0.5 is 0.25, plus 0.5 times square is the same. And you have here really, you add them together, we have 0.5. So to get the length of c is we're going to get the square root of this. So the square root of 0.5. Well, let's just 0. Let's do it properly. 0.5. There you go. So in this sense, we try to get the help of our calculator. So it's 0.5. The square root of 0.5 should be 0.707. Well, let's have 2 decimal places for this. So it should be 0.71. Now we have the value of c, and now we could get the perimeter. Yeah, we can get the perimeter of this. So this one here is 0.71. This one is 0.71. This one is also 0.71. And that is also 0.71. So now we can get the perimeter of these smaller squares. So the perimeter of small square, or the inner square, is essentially adding all the sides. So it should be side 1 plus side 2 plus side 3 plus side 4, which is essentially 0.71 every time, because all the sides of a square have equal length. Now what is 1, 2, 3, 4? Yeah, that's right. So 0.71 4 times 0.71 times 4 is 2.84. And so now, yeah, we can see it. Archimedes then said that, oh, now I know what is the approximate value of pi. Now, Archimedes knew that he would never get an accurate value of pi, but he can make it so accurate. And so the value of pi for Archimedes is essentially, pi for Archimedes should be bigger than, pi for Archimedes should be bigger than the perimeter of the smaller square, which should be great. Pi is, we shouldn't put equal sign there. Pi is greater than 2.84, which is the perimeter of the smaller square, but it is also, pi is also lesser than the perimeter of the bigger square, which is 4. And so you have to think about this now, that these are the estimates. Now, when we see, if you really calculate the exact value of this one, it's really 4, yeah, plus 2.84. We average that, we get the average of the two values divided by 2. We have a value of 3.42. Now, that's not very accurate, isn't it? So here, the value of this is really around pi, then is around 3.42. Yeah. Now, why is that not close to our modern equivalent of 3.14? Well, it's only like that because we are only having an example, all right? Originally, this is how Archimedes did it. What he really did is he didn't only use a square, he inscribed the circle with more number of sides. Instead of just having 4 sides, he increased it into what I call more sides. So let's say we put more sides into this. There, there, and put another side. Now, let's just say here. So he inscribed it with an octagon. So here, there you go. It's easy to draw it with upside down. Yeah. So that figure here, one, yeah. How many sides is this? 1, 2, 3, 4, 5, 6, 7, 8. So that's an octagon. Now, how can we find the perimeter of that octagon? And that's really the homework, is the more sides there is, the closer we are to the perimeter of the circle, which is really the circumference. So homework is find the perimeter of the octagon inscribed within the circle. That's your homework. And so how do you get that? Can some of you, or you could go into groups and work it out. How do we get it? So there's essentially we can use Pythagorean Theorem. Yeah, but there's another step that you have to do. Okay, let's see what you got for tomorrow. Right, see you. Bye.